Solve y double prime minus 2y prime plus 2y equals 3 times e to the x times secant of x. In this example, I'm going to show you the small shortcut you can take to make these variation of parameters problems go a little faster. To start, we still need the complementary solution yc. So I encourage you to pause the video, find yc yourself, and then press play and compare your answer and work to mine. The characteristic equation is r squared minus 2r plus 2 equals 0, which can be solved using the quadratic formula. So r is 1 plus or minus I. So yc is c1 e to the x sine x plus c2 e to the x cosine x. And that is our complementary solution. Now we still make the same substitution, letting y equal y1 v1 plus y2 v2 with the constraint that y1 v1 prime plus y2 v2 prime equals 0. And in this problem, y1 equals e to the x sine x, and y2 equals e to the x cosine x. So yp equals e to the x sine x times v1 plus e to the x cosine x times v2. But we aren't actually going to plug it in. Instead, since these problems always follow the same pattern, we are going to jump straight to the system of equations that we need to solve. y1 v1 prime plus y2 v2 prime equals 0. That's our constraint from earlier. And y1 prime v1 prime plus y2 prime v2 prime equals f of x over p naught of x, where f of x is the non-homogeneous term and p naught of x is the coefficient on y double prime. In this problem, f of x is 3 e to the x secant of x, and p naught of x is 1. This is as good a time as any to point out that since our non-homogeneous term has a secant function in it, the method of undetermined coefficients wasn't going to work for this problem, which is why we're tackling it with variation of parameters instead. We certainly could have used reduction of order, though, if we had wanted to. Plugging in our y1, y2, f of x, and p naught of x, we see that the system we need to solve is e to the x sine x v1 prime plus e to the x cosine x v2 prime equals 0, and the derivative of e to the x sine x v1 prime plus the derivative of e to the x cosine x v2 prime equals 3e to the x secant x over 1. Using the product rule, our second equation becomes e to the x sine x plus e to the x cosine x v1 prime plus e to the x cosine x minus e to the x sine x v2 prime equals 3 e to the x secant x. Now we're ready to start solving. Notice that we were able to cut out all of the steps where we find y prime and y double prime and substitute them in and simplify. We still have a lot of work to do, but at least we don't have to do all of that. The nice thing about the system in this problem is that every non-zero term has an e to the x in it. So we can divide both sides of each equation by e to the x and cancel all of those out. Now you can solve this system by whatever method you prefer. I tend to use Cramer's rule, but that's just personal preference. Again, I encourage you to pause the video, solve this system yourself, and press play when you're ready. If you choose to use Cramer's rule, you have to set up a matrix equation. The determinant of the coefficient matrix A equals sine of x times cosine x minus sine of x minus cosine x times sine of x plus cosine x, which equals sine x cosine x minus sine squared x minus cosine x sine x minus cosine squared of x, which simplifies to just negative sine squared x minus cosine squared x, which is just negative 1. Next, we need the determinants of a1 and a2. The determinant of a1 is 0 times cosine x minus sine x minus cosine x times 3 secant x, which is negative cosine x times 3 over cosine x, which is negative 3. And the determinant of a2 is sine x times 3 secant x minus 0 times sine x plus cosine x, which is sine x times 3 over cosine x, which is 3 tangent x. So v1 prime is the determinant of a1 over the determinant of a, so negative 3 over negative 1, which equals 3. So v1 is the antiderivative of v1 prime with respect to x, so the antiderivative of 3 with respect to x, which is just 3x. And v2 prime is the determinant of a2 over the determinant of a, so 3 tangent x over negative 1, which is negative 3 tangent of x. So v2 is the antiderivative of negative 3 tangent x with respect to x, which is negative 3 times the negative natural log of the absolute value of cosine, so 3 natural log of the absolute value of cosine. This is an antiderivative that I have memorized. If you didn't know it, you could look it up, or you could write tangent as sine over cosine and do a u substitution. Now that we have v1 and v2, we go back to our original formula for v prime and plug them in. So we had written that yp was e to the x sine x times v1 plus e to the x cosine x times v2. So our particular solution is e to the x sine x times 3x plus e to the x cosine x times 3 natural log of cosine of x. So to get our general solution, we add on the complementary solution to get our final answer of y equals 3x e to the x sine x plus 3 natural log of absolute value of cosine x times e to the x cosine x plus c1 e to the x sine x plus c2 e to the x cosine x, which if we wanted to, we could rewrite as 3x plus c1 times e to the x sine x plus 3 natural log of absolute value of cosine of x plus c2 e to the x cosine of x.